continue with the discussion of vector GIS. And you'll recall again that a vector is just a drawing with some coordinates in GIS. And right now, what you're looking at is a figure that I developed for a paper that I co-author with Raul Lejano from New York University. And this paper is going to be published in the Annals of the Association of American Geographers real shortly. It was just recently accepted for publication. And I want to show you how I went about in drawing this particular figure. What it displays is it displays land uses in the northern part of a city. The city is Huntington Park, California. And basically what it's depicting are the various land uses, and it's showing like basically an extreme case of mixed land uses where you see houses really bordering right next up to some firms and so forth. And so basically this is a vector or a drawing done in GIS, and basically I just drew these rectangles right on top of a raster. So here, let me show you what this looks like. So here is the section of Huntington Park. It's in the north part of the city. And this is the area where I drew this particular figure. So how do you go about drawing vector diagrams or vector features in a GIS? Well, first we need to create a geodatabase. So let's create it using the Microsoft Jet Engine. Again, the same jet engine that's used by Microsoft Access. I'll right click on this and choose New Personal Geodatabase. And I'm just going to name this Personal Geodatabase, let's call it Drawing, since that's what I'm going to be doing. And so basically what I'm going to use is this drawing tool, and so I've ported it on the bottom of my ArcGIS, but you can open it by right-clicking just up here in the empty tool place and making sure that draw is checked. And then I ported it right down here, which is where I like to have it. And I'm just going to use this rectangle tool, which basically, just like any drawing program, allows me to draw a rectangle. And so here, right here, I'm going to go for this X-ray laboratory facility. And I could click on that rectangle and then just draw a box around it like so. And then I'm also going to draw a box around this parking lot, a rectangle. There's a little parking lot right here and an empty lot. And then there's some other activities right here that I'm going to draw as well. And I'm going to just start. You could see there's multiple land uses down here. There's some houses and so forth. But I'm just going to start with a simple rectangle because I want to show you basically this concept of a spaghetti structure. So now that I have those, I'm going to go ahead and select all of those drawings, those drawn rectangles. And I'm going to go up here to the data frame. I'm going to right click on the data frame name Layers. And that'll allow me to convert these graphics to features. So I'm just going to go ahead and do that. That pops up the screen. And again, I'm going to put it in that geodatabase that I just created. Again, these are polygon graphics, little rectangles. And now I just need to browse to where that geodatabase is located. It is in my data folder. That's in the correct spot. But I need to change the type from a shapefile to a geodatabase. Now, I mentioned earlier that a shapefile is a spaghetti structure, and that's true always of shapefiles. A geodatabase feature can be either a spaghetti structure or a topological structure. So in this case, of course, I'm drawing it as a spaghetti structure to illustrate that point. So I'm going to put it in drawing, and we'll just call this uses for land uses, and I'm going to say save and say OK. And then that allows me to add it to my table of contents. I'll go ahead and say yes, and you see it's here, but still on top here are those ones that I created. These are still just simply graphics on top. In other words, the difference is that these rectangles don't have are not mapped to coordinates on the Earth's surface, but when I converted them to features, I basically gave them spatial locations. So when I deleted that with the delete key, now these are features. These are the ones over here, and I could, of course, now change the color, say to like a red or something, or what have you. So in essence, what I've done is I've made these essentially a mappable item. They now have locations on the Earth. So now they are part of a geodatabase. That's the distinction. So in addition to that, I can edit these and in a process that we call in GIS digitizing. And so I can open my editor. Actually, my editor is already open, but by right clicking on here and making sure editor is selected. So I'm opening up this editor. I'm going to turn this on to start editing. And then basically what that will allow me to do is it brings up some tools here, and it allows me to modify these so I can basically split this up a little bit and get at those other uses in this bottom rectangle. So I'm going to use this particular tool, which is really helpful. It's the Cut Polygons tool. And again, I'm doing this so I can demonstrate what a spaghetti structure is. So I'm just going to split these polygons into multiple polygons using this Cut Polygons tool. And so here I'm going to split this right about there. And again, I'm kind of approximating what I already drew. And you can see now there's two polygons. Now I'm going to cut this one in half this way. And basically I'm adding those houses. So cutting these, whoops, that's not, whoops, that actually did work, but I'm gonna do an, no, that's fine. And then cut this as well. Okay, so basically now you see that there are multiple polygon features, and stop editing and say yes. And so basically, again, here's what my drawing looks like. It's a little neater because I took a little bit more time in creating it. And of course, I added labels and stuff. But the point that I want to exhibit here is that this is a spaghetti structure. Remember that I mentioned that local governments in particular, your assessor's office and so forth, are going to use topological structures so that there aren't gaps between property ownership boundaries, particularly your lots. And the reason for that, of course, is because it's important. Those properties are owned, and we need to be accurate. So again, a topological structure relates the actual points, the nodes, in each polygon to the polygon. So two polygons that are adjacent will share the same node, will share the same edge in a topological structure. They don't each have their own edge. In the other case, in the case of a spaghetti structure, they're completely independent. So even though I split these out, because this is a spaghetti structure, I can show you what this looks like. Let's select this one here, and I can move it out. So you can imagine, since these each have their own edge, there can be gaps. So when property ownership is important and accuracy is real important, it's important that we use a topological structure, is the lesson of this. So going from this, I can show you real quickly what this looks like. Here is the actual map that I drew in ArcMap. Let me turn on the base map around it, give you a little bit better picture. So again, vector GIS, simply a matter of drawings, but those coordinates, the geometry in those drawings, are pegged back to the Earth's surface and managed by the database. So that's what a GIS is. It's just a database that manages Earth coordinates for the various objects.